Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. Hello, everyone, and welcome back to the Fabrication Friday podcast. I'm your host, Joe Fairley, owner of Ascent Fabrication, certified prosthetist, and just overall 3D printing enthusiast. It's been a couple weeks since we've been back into the Fabrication Friday podcast. I know I've been saying this the last couple times. I think we're going to be actually trying to go almost every other Friday now at this point, until we can get back on the every Friday trend. So thanks for dealing with that, being a little bit more sporadic on the Fabrication Fridays the last couple of weeks. We've been super busy at Ascent Fabrication, honestly, which is a great thing, but having some good growing pains, so Ascent Fab is obtaining its 10th and largest 3D printer yet, the Filament Innovations Icarus. If you haven't heard of Filament Innovations, you definitely need to check them out. They are honestly, in my opinion, the leader in high flow FDM and large format FDM 3D printing in the entire industry. Honestly, I haven't seen, of a gantry style FDM printer of this caliber. And honestly, you can't get better support than Mike Gorski and his crew. So shout out to those guys. Go check out Filament Innovations and see what they've got going on. We've got a print of the week this week as well. The Fairley's Forest ornament. So this was actually very, very near and dear to my heart. This ornament, Fairley's Forest, comes from my grandmother, actually, who was an artist, and came up with this kind of family crest, if you will, that she drew out by hand, and then she had put on a couple different items around our house, maybe a trivet, pot holder, a couple of homey items. So I recently just visited my family this past weekend for my grandfather's 90th birthday. And he was thrilled to receive this Fairley's Forest ornament. The whole family was pretty excited. So it was kind of neat for me to, go ahead and re-sketch out that old design that my grandmother had done and gift this ornament for their Christmas tree for this Christmas. So that was a really, really cool thing that I got to do this past weekend, and show my 90-year-old grandfather what 3D printing is all about. So really, really cool. My 91-year-old grandmother as well is just as stoked about 3D printing, as my grandfather is now and I am. We're actually going to be working with her senior center locally in Fort Worth area in Texas, and going to be putting hopefully an artillery sidewinder 3D printer into the senior center there, which will be pretty fun. Get the seniors engaged with some more, high-techy type stuff, and show them, what 3D printing is all about in their crafts oriented, section of what they do in the senior center there. So my grandparents are rocking it, and, really interested in trying to utilize some kind of 3D printing in the senior center. So we'll see what they can do. That print of the week this week, though, for the Fairley's Forest ornament was about 30 grams and about an hour and 36-minute print, with a 0.6 millimeter nozzle on the artillery sidewinder. And that was printed with Color Fab's Stone Fill Moss Green filament. Really, really neat filament, honestly. It kind of feels a little, matte surface finish, a little rough. It just gives it that texture, kind of pops off that ornament. So really cool ornament that I got going on there. And now it's going out to one in every part of the family. So fun stuff going on last weekend. Today, we've got a really cool episode that was recorded here a couple weeks ago now with our good friends from the Victoria Hand Project. You might have heard that I have mentioned them a couple times now. We work very closely with the Victoria Hand Project. They're out of Victoria, Western Canada, and they're a nonprofit that offers upper extremity 3D printed prosthetic devices for people in need all around the world. You'll hear a little bit about, what their process has been getting to this point, working with different countries and actually putting 3D printers into these different countries so that you're empowering those local people to continue to have those jobs and expand their knowledge in more of this technological era. So I hope you guys enjoy this podcast. Let's listen in. All right. Thanks, everyone, for tuning back into the Fabrication Friday podcast. This week, we have a really great group of people actually coming onto the podcast, the Victoria Hand Project folks. So I've got Michael, Kelly, and Kim with me today. Michael, Kelly, and Kim have been very ingrained within the Victoria Hand Project, VHP, as we like to colloquially call it. And I've been working with VHP for quite some time, off and on over the last like 6 years, actually, starting in like 2017. So my journey into working with VHP has been a pretty long one, but today we get to invite them into the Fabrication Friday podcast and hear about their background stories into 3D printing and what Victoria Hand Project is all about. So thank you guys for coming on. Really appreciate it. And yeah, Michael, could you start us off with a bit of an introduction?
Yeah, certainly. Thank you so much for having us on the podcast. So I can give a little brief introduction on Victoria Hand Project and my background of how I got here. So Victoria Hand Project, we are a Canadian charity organization and also a US 501c3. And what we do is we design low-cost prosthetic devices and the workflows for how to produce them, including software. And we partner with clinicians around the world, and we provide them with the tools, the technology, and the training for how to produce these custom prosthetic devices themselves. So I actually first got here before Victoria Hand Project was Victoria Hand Project. It was a university research project run by Dr. Nikolai Dechev at the University of Victoria. And it was to study the feasibility of 3D printed prosthetic arms. And this was done in Guatemala in 2014 with Range of Motion Project, ROMP. And at the end of the study, the participants were actually asking to keep the devices because they didn't have one of their own. And this spurred the idea for actually starting a company that could provide these around the world. So I joined as a volunteer and then a cooperative education student, a co-op student, sort of like an intern. And then in 2015, VHP actually started as a company, was established. And then from there, just grown to a variety of countries around the world. I did a second co-op where I went to Nepal in summer of 2016. So that was a pretty fun opportunity as a student to be able to go over there and, work with the 3D printers, work with some of the patients and the clinicians. And the way that I actually got here and got involved as a volunteer in a co-op was I was studying biomedical engineering at the University of Victoria. And I think at the time, Dr. Dechev was the chair of biomedical engineering. And then I heard about his research and I was like, oh, that sounds really cool, like 3D printing and design of prosthetic hands. And that's sort of how I first got involved with VHP. And the first time I saw 3D printing, which was some of the earlier Ultimaker printers and also a Form 1 printer. So way back in the SLA.
Sure.
Yeah, that was in 2014. So that's how I first got involved with VHP and 3D printing in general.
Yeah, so going all the way back there to 2016, 2017, and kind of my introduction into VHP, there was another individual that had kind of helped spur this project on, right? Joshua Coots. who I got to work very closely with in that first trip to Port-au-Prince, Haiti. So one thing that I really enjoy about, your approach at VHP is that you're providing those, training tools and the workflows, the software, the hardware for setting up those clinics into having the easiest way possible to providing some of these devices that you've already designed, right? So that was kind of our initial approach to Port-au-Prince back in 2016, 2017, where we worked with a clinic and Josh was involved back then, where we were trying to, like you said, the feasibility, right, with ROMP and making sure that these devices were actually providing what we thought they were going to provide to the patients, that they were functioning well, that the patients were giving us feedback on what was good and bad about them. So I really appreciated kind of working with Josh back in the day, and now with you all. Kelly, could we get you introduced here next?
Absolutely. Hi, everyone. My name is Kelly. I've been involved with Victoria Hand just a couple years after Michael did. I started in 2016, so right after Victoria Hand Project had just been established as a nonprofit entity. My background is also in biomedical engineering, so I kind of ran into Victoria Hand Project by accident initially. As a student, I just saw that this project was happening. It was based on campus since it was born out of that research project. And I thought this is such an interesting way to kind of apply the skills that I'd been learning in biomedical engineering and also be able to give back with that really incredible humanitarian aspect of knowing that the work you're doing, people are actually benefiting from that and it's changing their lives in a lot of ways. So when I first started out, I was doing a lot of little tasks. I was doing website, I was redoing the website, I was editing photos, I was assembling a hand, but the volunteer team was so small at that time. I would assemble a finger, I would assemble a second finger, and the co-op student would steal it to use it for something else. And I would assemble another finger and another finger, and it would get stolen again. And so finally, I think after 2 years of volunteering, I was able to complete my first hand assembly and monumental moment. And yeah, so I volunteered for a couple years, and then I was able to also do my final cooperative education final degree work placement at Victoria Hand Project. And that was a really incredible time to be working with Victoria Hand Project. We just received a grant from google.org, which had allowed for rapid expansion to a lot of our different partner clinics. So there was a lot of work going on, making sure that these partner clinics had everything they needed. There was also a lot of work happening with designing the hand and trying to make sure that it was more durable and more functional based on the patient feedback that we were getting from all of these new people that were receiving the hand. So I remember as just a little undergrad student, my first project was designing a force doubler mechanism for the hand. So it was a very simple block and tackle slider, mostly 3D printed with a little metal pulley, and it was ideally supposed to double the pinch force of the hand. So that was a really cool project to work on. And it was really neat as a student to then see that be incorporated into the hand design and be used all around the world. Yeah, so after my co-op, I continued to volunteer with VHP kind of throughout the rest of my undergraduate degree. And when I graduated, the stars kind of aligned because VHP received funding for another full-time staff member, and I was able to start as a biomedical systems designer. So I was doing a lot of little engineering tasks, design tasks, and also just a little bit of everything because we are a pretty scrappy small team. And yeah, a couple years later, I've now kind of moved into my chief operating officer position. I'm doing a lot of coordination with our partners, overseeing of operations, and then working with our design team to do all that product development and everything. Yeah, it's been an incredible ride, and it's been so cool to see how much has changed even in the last 5-6 years.
So yeah, you're wearing a lot of hats then too,
Yeah.
and definitely a very dynamic team over there at VHP. It's awesome to see just the amount of engineering that goes into that single prosthetic hand, right? And then of course all the other components aside from that. So yeah, I've always been very impressed with that design and how it's been iterated upon over the years. So really cool to see that evolve firsthand, pun intended, firsthand. Right? Yeah, Kim, would you introduce yourself as well?
Yeah, of course. So my name is Kim, and I'm a mechanical systems designer with the Victoria Hand Project. And I became involved with the project in, I think it was fall of 2019. I was an undergraduate student at the time here at the University of Victoria. I was studying mechanical engineering. and there was UVic was putting on a health hackathon event. And so it was an event that a bunch of different companies approached UVic and had this project that teams of students could work on. And so me and 3 of my colleagues, we collaborated to design this personal assistive writing device that was compatible with the Victoria hand. And so we did that through using the 3D printing technology that VHP had in their lab. And we developed this device, went through like all the prototyping and iterations of it. And that was really my first opportunity to get hands-on experience with 3D printing.
Mm-hmm.
And so that was, I had heard of the project a little bit before that, but that was when I first became involved. And then after that competition, I was like, hey, this is such a great project, an amazing initiative, and such a cool way to use 3D printing. And so I continued volunteering up until, I guess it was only the following summer 2020. I was a co-op student with the University of Victoria, and I did some part-time work here with VHP. And then in fall 2020, I did a co-op. It was my 5th co-op in my undergrad. And that was where really got to get like hands in on the 3D printing.
Right.
So through that term, we were kind of developing the VC300 had just come out and been released the previous spring. And we were working on the new small hand with the laser cut parts. So that was such a great hands-on, no pun intended.
Gonna be a lot of puns in this episode.
Yeah, I think we just
this is great.
To get that, hands-on experience of 3D printing and how amazing it is and how quick the prototyping is, and just you can design something on your computer and print it out in a couple hours and be like, yeah, does this work? Or no, it doesn't. What am I going to do? And I'm going to see it tomorrow. And then incorporating the other hardware and the stainless steel links and everything to get this product that's strong and durable and for a great cause. So that co-op was in fall 2020, I guess. And then I went back to school, finished my undergraduate degree in mechanical engineering. And then I joined the team full-time in fall 2021 as mechanical systems designer. So yeah, over the past 2 years, it's been a big ride. The team has I just can't believe how much even the past 2 years, what has been accomplished by the team. And so a lot of my day-to-day operations is working on the design of the hand, the software that goes along with creating our hand to make it easier for the clinicians. And yeah, that's kind of my day-to-day. So
yeah, no, there's definitely, again, a lot involved with putting together this team, putting together all the nuances of not only coming up with your own device, but then, being able to actually scale that out to other countries, right? Michael, how many countries are you involved in now?
We're in 11. Sorry, we had 2 countries added this year, so it's trying to remember the number.
Sure.
But I'll just list them off because that might be easier.
Yeah.
Nepal, Cambodia, Guatemala, Haiti, Egypt, Uganda, Kenya, and then we also expanded to Pakistan in May of 2023 and Ukraine in June of 2023. And then we also work in Canada and the US, and we work in the US partner with Ascent Fab.
That's right. That's great. Yeah, we're starting this out, hand by hand, coming up with, which was kind of funny, right? The first order actually is going up to Canada, but over on the eastern side of Canada. So, it's still closer to me than it is to you, I guess. But yeah, I guess that just, proves a point that, we've been working really well together and have this very similar mindset approach around how 3D printing can be implemented in these places. So, and this could be a question for any of you here, but in your eyes, why do you see this technology being best utilized in some of these third world countries, war-torn areas? Why has it been a central approach and theme for VHP to go to these places and help empower those people to be able to use this technology for their own patients?
So Victoria Hand Project is primarily focused on amputees in need of a prosthetic arm who are facing barriers to care, whether that be cost, whether that be location, or whether that be a lot of the challenges that come with a lot of these war-torn areas, areas with conflict. And I think 3D printing has really allowed us to do the work that we do. In a lot of the areas we work, traditional prosthetic care is very expensive. It's very timely, and it requires a lot of specialized labor to do. And a lot of these people just are not able to afford that care. So one big advantage of making our hands with the 3D printing is that we are able to keep the costs extremely low, especially for the terminal device. We're able to manufacture everything. And we also give a lot of that power back to the clinicians that we're working with. Instead of needing to rely on logistics and supply chains and needing to order in these very specialized componentry, they have these 3D printers in the clinic and they're able to create everything they need on site, on demand. So that's a lot of flexibility. And if a patient approaches and they're not able to receive traditional care for whatever means, our clinical partners can then fall back and say, well, we have everything we need to build a Victoria Hand prosthetic arm end to end. We can assemble the terminal device here. We can create the custom limb socket and print it. Everything can be done just on site as needed. It's really convenient, really good for repairs as well. If anyone ever has any minor breakages, they can just come back to the clinic within their own community, print off a new part, get it fixed overnight. Very quick. I recently returned from a trip to Ukraine in June where we were opening a couple new clinics there, and that was just one of the biggest things because they're having huge problems logistically getting these parts. So there's been huge delays. There's also, unfortunately, a really huge need, which is overwhelming the way the current system is. So the Victoria hands had a really special niche in that way, where if the hands were assembled ahead of time, a patient could ideally come in, be measured, have their plaster impression taken. The clinicians could then scan that, go through our software to make the socket, print the socket overnight, and ideally, a patient would have then a working prosthetic the very next day. So very quick turnover. We're able to help a lot of people all at once. Yeah, it was a really good fit for an area like that. But also all around the world, just being able to provide these clinics like another option for people and a way to help people that maybe would have fallen outside of their clientele before.
Right. Yeah, I couldn't agree more. From the impact that I've seen firsthand, with VHP in Haiti, having gone to Port-Au-Prince 3 times myself, which is an adventure on its own. Whereas, bringing the first 7 Ultimaker printers, if anyone from Ultimaker is listening, watching, thank you for supporting what we've done in the past, with VHP. You've been an awesome partner. Would love to continue to work with you in that respect too. But yeah, we brought down those 7 printers in, black rucksack bags and had our clothes inside the printer and, got them down there. It's definitely a logistics issue trying to, get some of these, printers and other equipment and scanners and maybe outfit them even with computers sometimes as well, trying to get all those logistics and not to mention filament. I'd love to dive into that a little bit too about some of those logistical problems that you guys have seen and how you've overcame those. But trying to continue to have it be sustaining, I think, is a very difficult thing to do. And I've seen it firsthand, work out very well for you guys at VHP. So, kudos to you for the time and effort you put into trying to build up, again, that sustainable approach to, being able to empower people on the ground there to learn these skills and to use the printers and coordinate with you for support that way. With all the different places that you're in right now, I guess where we've heard a little bit about Ukraine, let's talk about maybe a couple of the other sites. Who is kind of the most active site right now, would you say? And are they mainly doing, transradial devices, transhumeral? Can you take me through kind of what devices you're seeing?
Yeah. Our partners in Kenya have been doing a lot over the past few years. So we actually expanded there in February 2020, got home like 2 weeks before the world shut down. So that worked out well. And they have continued to fit the prosthetic devices. Obviously, there have been some delays due to COVID, but I think they said last year they fit like 50 Victoria hands. So that's pretty amazing of them.
Yeah.
So they have been primarily fitting transradial devices. That's because, this is the technology that we've had since 2014. It has improved a lot. Kelly's holding up a device showing
There we go.
the transradial samples. But recently we actually have also released the transhumeral device. So this is something that's actually been in production for quite a while. There's actually one behind us. I'm not sure how well you can see it because you can kind of see it.
Yeah.
Oh, the old one?
Yeah.
There's on Spotify here or something. You definitely have to go to YouTube and check out the video.
Yeah, you gotta zoom in there. It's on the wall in the back, but we tried to do like a rubber ball and socket elbow, sort of like how our wrist operates. But unfortunately, when it's locked down, like the elbow is closed, and then somebody has weight in their hand, with that, like the torque that's on the hand, it would rip the rubber out. So we had to go back to the drawing board. And it was only really by implementing laser cut stainless steel links into the hand and other parts that it made it possible to make a strong and durable elbow. So Kelly's actually holding up one right now. So everyone should just check this out on YouTube so they can see everything. And it's just a ratchet and pawl mechanism in the elbow. And so that made it possible to have a strong enough mechanism for that. And then also with the software that we've created that implements with Fusion 360 and sort of like a front end and will automate the process of creating the prosthetic devices. There are people that can go through that process and it would be very straightforward for, like yourself, Joe, has a lot of experience in CAD, but many of our partners around the world, it's when we work with them, it's really some of the first times that they actually see 3D printing or CAD. So to just be like, go through this workflow and, have to do all this stuff. And I think, Kim, you said it took you like 40 minutes in the past, or like, I don't remember how long before the software.
Before the software. Yeah, even maybe upwards of 40 minutes, an hour, especially for a transhumeral system, which is a lot more complex to create the socket and other parametric components.
Right.
Yeah. Right. And then now with the software, it makes it much easier because we'll automate and step through the workflow. And then it can be like 15 minutes or so to produce the device. And then Kelly, do you mind holding it up again?
Yep.
And then this actually has a shell that's just offset from the scan, and then a lower portion that's just sort of a parametric model. And these are two separate parts that are created, and then they're merged together and then blended. So for people that are on video, you can't really see a seam at all because it doesn't exist.
It's super elegant. Yeah.
Yeah. So it's the combination of both the laser cut elbow and the software that's made this possible. And I think that was a big side tangent to your question.
Yeah.
No, that's okay.
But a little bit of background. So then also for our partners in Kenya, thank you. I was there in September and I showed them the workflow for how to produce the transhumeral devices now. We fit 6 people when I was there, but the waiting list is very long. So we'll just continue to fit people transradial, transhumeral in Kenya. And we're also rolling it out to our other partners. We have talked about Ukraine a lot earlier in this conversation, but there is a great need for transhumeral devices due to the nature of many of the injuries that the soldiers are facing. And there aren't many transhumeral solutions. So our partners in Lviv, I was just looking back on a report that they sent, and like probably 70% of the people that they fit have been transhumeral. And it's because many of the soldiers, as they're at the rehab hospitals or, in the community, there's other people that are approaching them saying, where did you get that device? I've been trying to get one. And then they get led to our partners in Ukraine, and then they can produce the custom prosthetic devices.
Right. Yeah. I mean, again, it's a worldwide approach that comes with a world of logistical, hoops to jump through sometimes. I guess let's get into some of the nitty-gritty of the 3D printing aspect of things. We mentioned Ultimaker. What are some of these? I know a lot of the workflows have been built around the Ultimaker printers. Are those the only printers that you use in these situations? And if so, why? And with some of these materials that you're using as well, could you kind of go through some of those decisions of what has been done so far?
Yeah, cool. Sure. I'm happy to talk about that. Yeah, for sure. So we originally, when the project was first starting out, there was a lot of different printers that were trialed. Like Mike was mentioning, we were trying like Formlabs, lots of stuff. We found that FDM printing worked a lot better in these prosthetic clinics just because they were so dusty and they weren't as sensitive as other printers might be to lots of debris and change in temperature and all sorts of things like that. And the Ultimakers we kind of have settled on because they have been very, very reliable. And we're able to give them to our partners all around the world who don't have that 3D printing experience. And they're able to use them very consistently without them breaking, without needing to fiddle around a lot. And of course, a lot of that is Victoria Hand Project behind the scenes will go through and we try to make it as usable as possible. So all of our hand parts have pre-sliced G-code that we've made sure to mess with the settings, make sure that they will print consistently. And we also have the same printers that our partners will have in country. We have mirrored printers here in the lab. So if something's going wrong, we can kind of have something right there that we can look at, we can open, we can take apart. And then hopefully much easier for remote fixing of these printers and everything like that. So we really love using the Ultimaker 2+ Extendeds. They were our favorite printers. They worked so well. They were easy to service. And they were tall enough to fit the limb sockets, which are sometimes really long, depending on the person's arm length.
Yeah.
And especially with the transhumeral, our over-the-shoulder patients, those are really, really big sockets. So we at Victoria Hand Project were devastated when Ultimaker discontinued the 2+ Extendeds.
Yeah.
We said, no, those are the printers that we use everywhere. We wish you would bring them back. So recently we were really happy that Ultimaker did, they relaunched the Ultimaker 2 Connect. So it was the 2 printer, which we knew and loved, but it had Connect capabilities. So you could connect USB sticks instead of SD cards. It had Wi-Fi, everything like that. But unfortunately, it's still short. It was the little cube. So right now we've been scrounging the internet trying to find as many 2+ Extendeds as we can. But going forward into the future, we know trying to look at that similar price point, we will probably have to branch into other printers that are available. So it's definitely been on the horizon for us just to see what's available out there. And especially in a lot of our clinics that are really busy and fitting a lot of people like Kenya, like Ukraine, they really need more printers right now to be able to keep up with that demand, especially with those, big upper limb sockets. Each of those patients would require 2 big prints because it's the forearm and the upper limb socket. So yeah, we're trying out a couple different things. Maybe Ultimaker will have a nice price point, taller printer in the future. That would be really, really great. Because we have found, just great reliability with these printers and being able to know that they'll print what we expect all over the world. As for filament choice, I don't know, Mike, do you want to talk a bit about the PLA we use and everything like that?
Yeah, so right now we're using the BASF Forward AM Pro 1 PLA, and we are very grateful because Forward AM does support our work around the world through filament. We are using PLA because we found that it is much easier for our partners to print with. Since I mentioned some of them don't have the experience with 3D printing, if we start to give them other materials that we know will have applications in various parts of the hand or the system, it might be more difficult for them to print with. To be honest, we have tried printing a lot with polypropylene for another project, a research project, and it was giving us a lot of trouble. So we're thinking, to give that to our partners, it might be difficult. But we also know that the materials, the printers, and the slicing software are improving. So it's something that, we try to keep up to date on and seeing if, there are components that could be made using other materials. Also with the PLA, the material that we're using, it can be against someone's skin for long periods of time. So if somebody's wearing a device without a liner, we can feel pretty comfortable that it won't have adverse effects like ABS or some other materials. So that's primarily why we're using the Pro One PLA. Also, we print all of our systems in black. So Kelly was holding some up, and there was the black trans radial system. What we've actually found by doing material testing, since we are at the university, we can do lots of strength testing. The black material is much stronger than other materials. This is sort of what we found in our results. We think it might be the additive for the coloring. And then we also will just paint the device after to closely match someone's skin tone. So the device that Kelly's holding right now, it is a black system, but it's painted. And many of the users around the world will ask that it is painted, just so it's more subtle. Also, if we are printing in different colors of material, like sort of skin tones that I remember LimForge was doing before, it becomes very difficult to stock them around the world, stock the different colors. So inventory gets very difficult. So that's sort of why we're going down this path right now of just painting the devices, and then we can get also more variety of colors and skin tones.
Yeah, definitely makes sense with more of the availability in a local setting of having spray paint or other paint more readily available, in many more different colors than trying to stock 6 different shades of skin tones in either flexible filaments or rigid filaments. So definitely a nice approach to being able to provide people, that little personalization touch to it as well, and more subtle touch, right? Because what we found with some of these devices as well is that, some people really enjoy the fact that it is 3D printed. That's a wow factor to it. They want it to look almost as gadgety as possible. But then there's the other half that want it to more blend in and just be able to fill up their sleeve and, have it even be more cosmetic in nature in some ways. So having that, skin tone approach definitely adds that next bit of human nature to it. Now, I guess with the Ultimakers, we talked about the filament with PLA. Because I've had experience printing it and using some of the arms, I know that these parts are extremely durable. But I guess could you go into some of that nitty gritty of like how much can it actually hold? Have you guys done any poundage testing and breakage testing on some of the finger components or wrist components, elbow components? And I think it's good to note that, again, 3D printing might not be the answer for everything, for every part of the device. You mentioned laser cut metal parts in parts of these hands. So I do think that adds, just a little bit more of that strength to it. But yeah, could you touch into those details a little bit?
Sure, yeah. So up until 2019, the hand was, other than the hardware and the pins in it, it was entirely 3D printed. And then over the years, we did, of course, receive reports of breakages of the finger or different areas in the thumb. And so here, Kelly actually has some old hands, so we can do a through the history. So this is also why everyone listening should check this out on YouTube, so you can see these super cool old versions of the hand. So this was actually the first 3D printed hand. So this was almost an exact replica of the hand that Dr. Nick Detchev developed in his master's, but it used the 3D printing technology to make it low cost and accessible and affordable. From there, we kind of bulked it up. So you can see size-wise, the links are a little bit bigger, a little bit more durable, but all of the internal linkages are still 3D printed. So this is where functionality-wise, printability-wise, it was great. It worked phenomenally. But there were reports of breakages in certain parts of the fingers, the thumb. There's only so much that the parts can be beefed up before, like, ultimately somewhere else will break. So in 2019, I think the development of the V300 hand began, and that was where we started to switch out those internal linkages in the hand to be stainless steel laser cut parts. So this allowed some of the hand parts to be shrunk down a little bit, and then the laser cut would be encased by the 3D printed. So the stainless steel part was really what started to carry that mechanical load and make the hand more durable. Parts of the hand were able to be slimmed down to be more aesthetic. So we were able to just increase the functionality and cosmetics of the hand over time. What was the question again?
Yeah, getting into with that, trying to go from 3D printed parts to metal components.
Yeah.
What's like the weight limit of something that it can handle? Have you guys
Oh.
done any, different, destructive testing of some of these parts?
Yeah. So
We don't want to go on the record and say,
yes.
because I'm not sure if Kelly told you when she was there.
I know there's some patients that, definitely push it to the limit where it might not be as safe to do that. So I can understand why. But like go through what are some, daily task things that people are safely using the device for then, and using this in everyday use.
Yeah, definitely. So we really say the device is like a light duty assistive device. So assisting with the daily tasks that like opening a cupboard, carrying a bag, holding a phone, helping prepare food, laundry, dressing, all of those kind of daily tasks just give people that independence that they can do those tasks themselves.
Mm-hmm.
We do say kind of don't hold more than 2 kilograms it is right now, I think. And that really is to make sure that people aren't pushing the limit of the device. It can last as long as possible for them without them having to go back to the clinic and replace a part. So that kind of ties back into the question of like, how long does the hand last? And we say like as a light duty device, if you're using it as kind of we prescribe, it can last many years. There are users that have continued to use their Victoria hand for many years, is dependent on their limb and how the shape changes over time. But that also is one of the benefits of 3D printing, of if their limb shape does change over time, they can go back to the clinic, they can get a new socket printed off, but as long as their hand is in good shape, they can just get their old prosthetic hand put onto their new socket. So really increasing that adaptive and accessibility.
Right. Yeah. Have you had then some patients that have, swapped out sockets maybe and kept the same hand? Do you know if that's happened?
Yeah, I think you especially, I'm thinking of the one
In Egypt. Yeah.
Yeah, there was a younger boy that he was sort of first fit with an original, or not original, but an earlier version of the hand. And then it was actually the V200. So it was that one that Kim showed of the painted, where it's like sort of the thicker links, pre-metal links. And he was able to get one of those. And then as he grew, we understood that he got a new socket as well. So that is really the great part about 3D printing is, you can produce a new socket very quickly and easily. Also, it's easy to make the adjustments. If there are pressure points, then people can heat form areas, makes it much easier for that. And then also doing check sockets and stuff like that, which Joe can obviously talk more about as the
Sure.
But yeah, it's definitely adding in those capabilities for the sockets. People commonly ask us why we don't injection mold the hand. One thing is the cost would be extremely high for getting those molds made, but we are printing the socket in country anyway. The printers are there, they're working every day, producing the sockets, and then the hands are just another part as well. It can easily be 3D printed, and it also allows us to make rapid changes and then just send new files online.
Yeah, and I guess expanding on that, it really gives us as designers the freedom to make those iterative changes based on patient feedback really fast, and also get them back to the clinic incorporated in the workflow really fast, because we can send these files across the world instantly and they can just print it out on their printers instantly. So it's a pretty incredible kind of international collaboration that is made possible by having these machines that can just make something appear from nothing, really, right on your desk.
Yeah, no, it's super powerful to see how you can work with people from afar. One person that's near and dear to all of our hearts here from Port-au-Prince, Mr. Cindy Laurent. We've worked with very closely in the past, with the VHP system, and down in Port-au-Prince, he had his own prosthetics and orthotics clinic. While everything was still somewhat stable down there in Port-au-Prince. And you were able to help him out, send him filament and send him some designs for devices. I was able to work with him remotely, right on the video call screen, and go through these clinical aspects of what the patient needed in their socket or other device. And then we're able to just send him a G-code and go ahead and hit print, right? I think taking that barrier to entry education wise on every single part of 3D printing is also why this is so powerful to implement and scale in these different areas, where you guys have done so much development work. I don't even know if you've racked up the number of hours that each of you has been 3D printing now, but I'm starting to stop counting. With all that experience, you're able to push that out to all these different partner clinics worldwide, which again is hugely powerful. And 3D printing is enabling that, right? With the 3D printing aspects that we haven't touched on yet, like which are more involved, that probably these clinics aren't really going to be diving into, like slicer settings. Right, I'm sure you guys are printing day in, day out, and maybe still tweaking some of these designs with slicer settings a little bit. You want to talk about kind of that little journey, and hopefully not too many times banging your head against the wall, but there's always failed prints. But
yeah, there was a little lag there, so we didn't actually hear what the question was.
I think you said print settings, and different.
Yeah, I guess getting into the slicer settings a bit. What's kind of your iterative process to print something out that's this durable and intricate?
Yeah, so we are using the Kira slicer since we are using the Ultimaker printers. I'm sure there's some listeners that'll say, why don't you use this one? And part of it is our partners know how to use it, so it's easy for them. So to throw them a new slicer at them might be a little difficult. So for our settings, as Kelly mentioned, we do prepare the G-code set. So we'll lay out all the parts. We will use some of the modifier meshes as well. So we can select various parts of the hand. If there's the finger links, we can select the areas where we want this to be 100% infill and the rest can be 50. And, by having those variable infill settings, it can add the strength and durability where we need it, where we found that it might be more prone to failure. While, we don't want it to be all 100% because that uses more material, more weight, more time. And also, since it is a prepared G-code set, we can do all that here in Victoria. And then we don't need to have our partners, needing to do that themselves. They don't need to, have a modifier mesh and trying to align it and stuff like that. Like that would be quite annoying for them and quite tedious. So by having all of those prepared sets, we can just, give it out in the software, and then they can print it off and not need to worry about that. There are the sockets as well, which, since they are custom made, they are exported from Fusion 360 at the end of the software as a STL, and then the partners can just import them into Kira. They can slice them with the Kira profile that we have, and then just have it ready for printing. With the transhumeral, there have been some new settings that have we've had to figure out. Part of it is, Kelly, do you mind?
That's right. Yeah.
Thank you. So in the elbow, there is the rotation point. And we actually have had that break out of the forearm. And that's just because there's so much torque pulling on it. And even though there are the metal parts, the force moves on to the next weakest part, and it was just sort of like a cylinder sticking out, and it just ripped completely out. So now we're like, okay, that area now needs to be 100% infill. So we obviously can't make the forearm socket 100% infill, because it would just be heavy. It would take days to print. So then it's just some export settings that we've been able to figure out where you can export, this cylinder as one part and the forearm as another part, merge them together, and then just select that cylinder in Kira to be 100% infill. And it's just sort of like, it's field testing in a way. Like it has just been like, yeah, that's sort of like how we have figured out a lot of the settings. And then some of it is even carried forward from the past few years. We're sure there's some improvements that could be made to our settings, but it's also like, with the focus on the ongoing design and everything like that, it's, incremental improvements to stuff like that.
Yeah, and I guess, Joe, as you and all of your listeners probably know, it's kind of that trifecta there where you need to know how to use your 3D printer. You need to design your parts for 3D printing, keeping in mind the layer height and the nozzle width and everything like that. And then there's figuring out the print settings. Like, it's just as important as the design almost, because you're going to get such a different quality part depending on those settings. So we have lots of different considerations that have been made. For example, if we have a pin that we know will be under a lot of high stress, we'll make sure that the hole for that has more wall thickness just surrounding it. We have different sets for the different parts of the hand that will be adjusted accordingly. And so I feel like that, with those mixed modifier meshes where we're able to highlight those very, very specific areas to change the print settings, it's nice to have these kind of locked down. We've tested them, we know they work, and so we'll make changes as needed, but probably not very freely, because they work and our partners have them and they're easy to use. Yeah.
Right. Yeah, no, I would agree. I mean, I think, we've been printing out parts, with you guys now for, I guess a couple months since Kelly came out and visited us here. And yeah, we really haven't seen much need at all to change any slicer settings. We're a little bit more advanced than the average user, so we could probably always nitpick things a little bit, but they're super durable parts, super easy to print, and we know when we're just sending it to the 2+ Connect from Ultimaker that, like you said earlier, it's just going to work. So I think, again, that's kudos to you guys and your team. And all the development that's gone into that, because that's no joke. There's a lot of hours, spent figuring that out, and that iterative process of seeing what works in practice and what doesn't as well. From a mechanical standpoint or a logistical standpoint as well. So I definitely think there's a lot to be said for the process that you've come up with. Yeah, so with the partner clinics that you have right now internationally, what's kind of your initial process for bringing on one of these partners? Is it something that you go seek out? Is it something that they come to you first and you kind of assess if they're a good fit for it? Can you take me through some of that thought process?
Yeah, definitely. Sorry, do you mind if I give this back? Thanks. So yeah, with our partners, people normally ask how we find our partners, and most of it has been personal connections. So I use this example quite a bit, but there were 2 students that were studying mechanical engineering at the University of Victoria from Nepal, and their father started a orthopedic hospital there. So that was a natural bridge into Nepal and working at the hospital. The Limb Care Nepal, who we work with, they were based out of there. Now they've moved on and had separate space, but it allowed that partnership to begin. And Aman and his team have been doing amazing work over the past few years. We definitely have a lot of people that are contacting us, seeking out partnerships, and a lot of patients that are seeking devices in areas where we don't work. And we want to be able to expand to help new regions, but it also requires a lot of resources and time from us. So even with our partners that have been doing, producing Victoria hands for a number of years, they still do require support from our team here.
Mhm.
Whether that's material support. So, we have a lot of the supplies here in Victoria, and we'll just put together little packages and send them out. Or, technical support if they're producing a device and they run into some issues. People that might have unique limb anatomy, or as we update the designs and, roll out, say, the transhumeral device, we need to give them training on how to do that, how to produce that, how to fit it. So the more countries that we take on, we're stretched a little thinner. So if we are able to grow our core team here in Victoria, we will be able to take on more partnerships. We are talking with people in we've been trying to work in Syria for a number of years, and now it looks like there's a promising pilot project that might be happening there. And then there's a variety of other countries. I think Kelly would know best, but it would probably just be like India, Nigeria, places in South America, Central America that have been seeking out partnerships, and we hope that we could begin working with them. When we do start a new partnership, we will, develop a training plan with them. We've sort of figured out the training plan over all these trips, all the countries that I mentioned, where we will travel to the country and we'll do in-person training for 7 to 10 days. We will walk them through how to use the 3D printers if they've never used them before, how to assemble the prosthetic hands, go through our software, all aspects of that, and we'll do a few fittings, and we'll sort of run through it a few times just so it really sticks. And then we continue to provide support from here in Canada. When we do the training, it is similar to what you mentioned, going into Haiti, where you have the printers we use hockey bags because we find that it fits the printers well, and we are Canadian, so they're everywhere.
Gotta have some hockey into that.
Yeah.
And then, we bring the tools and the supplies, and we try to get as much on the ground as we can. But sometimes we just find it easier to purchase it all here and bring it in a few suitcases. So that's sort of like how the new partnerships start. And then as we have the new partners, there obviously is more back and forth conversations over, WhatsApp or email or something like that, just as they learn the process. And then as we become more experienced and more confident in it, then the communication doesn't stop, but it's less regular. So even with Ahmed in Nepal, we started working with in 2016, we still communicate over instant messaging, over email, if they run into problems, but it's much more rare just because they have developed that base knowledge in 3D printing and CAD.
Right. And then obviously the ongoing, need for filament, I think was the really big ongoing piece of support. Does all that filament come directly from you guys, or is it also sourced elsewhere and then shipped out accordingly? Are there any local entities to any of these places that you've been to that are helping to source some of this material as well?
Since we do receive support from BASF 4AM, either they will ship out some material from their warehouse in the Netherlands, or they can ship it here and then we can take it with us when we go on a trip, or we can send it out using DHL or another means. There are some of our partners that do have local filaments that they've been inquiring about, but we would want to do testing on it to ensure that it has the quality and the strength that we require. So our partners in Ukraine, they actually have a Ukrainian material, and we brought some back with us, and we did tensile testing on it, breaking the material, seeing if it's similar to what we're using. And we said, okay, that could be good for some of the sockets and not the components with a high requirement for tolerances, like the fingers. So it allows them to source them locally. They can, get it much quicker usually, and also usually it's inexpensive. But then for some of those finger parts, the hole tolerance might change, and then the pins are falling out, or it might be too tight and the hand doesn't function properly. So that's why we're like, okay, use this material that we know will work. We've designed the parts for this material. And then also made me think of some of the laser cut parts, which we have manufactured here in Victoria, and then we'll ship them out, just in a box with DHL, whatever we need. Keep on shouting out to DHL for some reason.
DHL sponsor us,
yeah.
please.
Yeah, that'd be nice, huh? That would help out a little bit.
But with the laser cut parts, they're, our partners have been asking, they're saying, hey, there is laser cutting here. Can we laser cut the parts? And it would be the same where if they are to cut them locally, we would want to first figure out the hole sizes that are required, because, variable by machines. And then, just like some test cuts. And then if it is fine and the quality is consistent, then they could cut them locally. But it's something that we don't, give out without, a lot of engineering and testing and stuff.
Right. Yeah. Making sure it's going to work and work consistently over time. Right.
Yeah.
With that thought, again, this theme around trying to build something sustainable in these regions that, now have a wonderful, locally supported system, with remote support, I think is extremely powerful. And definitely, there's a huge need around the world, continuing need, and there always will be, unfortunately. So, reaching out to, those places that are, in need of it most now, and trying to figure out how to make it work in those regions, I think is a pretty unique talent of VHP. So keep continuing to give kudos to you guys for figuring that out and continuing to work on it. I've always enjoyed working with you guys, and looks like we're going to be doing some few arm builds here in the near future. We'll see how we can collaborate in other countries as well. I think there's a pretty big opportunity for us to continue to scale out what we've been doing together. With some of our listeners, and just if they know about other clinics that could be in need, kind of what's some advice that you would give them to maybe initially reach out to you? Is there anything else that you'd like some of these listeners to know about how they could get involved with you?
And were you going to answer?
So I guess just kind of repeating what we said at the beginning, we are a charity, we are a nonprofit, so we are fully funded by public donations. So the biggest way that you can support Victoria Hand Project is with donating, with advocating for us, for spreading the word, because all the work that we do isn't possible without that help from our supporters and our donors. So we are so grateful for the people that believe in what we're doing and really make this work possible, because it just wouldn't happen if it wasn't this big rallying force and this big community that wants to help in the world. So that's the biggest way that you can help. We also have a very large volunteer team, which has been wonderful. We do mostly have volunteers in person in the Victoria area up in Canada, but every once in a while we have some remote tasks available. So if that's something that really excites you, definitely feel free to reach out. Anything else on your mind? Oh, I guess I will mention too, when it does look to us for expanding into different countries, we have a really long waiting list of countries that we would really like to work in. Unfortunately, there is huge need, and we even have places where we have a partner clinic we want to work with, but we just don't have those funds. So if anyone knows any ways to scale and to help us get our essential services to these other places of the world, advice is always appreciated. We definitely want to hear who you know and what you know, and we're open to a lot of opportunities.
Wonderful. Yeah, well said.
Yeah. Well, thank you guys again for sharing some of that insight into, what goes into creating and building the Victoria Hand, transradial and transhumeral device. I know that in the background, right, we've got some, I've got some lower extremity things that, we're trying to work on as well. So if anyone's listening to this and thinking, well, they've got upper extremity, where's the lower extremity? That's it's coming around. At Ascent Fab, we're doing a lot of testing on that side of things. Definitely reach out if you're interested in helping us test that out. We've already had conversations about Ukraine. Obviously, there's that big immediate need that we see there right now, obviously. But yeah, no, I'm just super thankful to be working with you guys. Thanks for your time today again, sharing what VHP is all about and some of your journeys into, 3D printing in general. If there's anything else that you guys would like to share here, and otherwise we'll have some contact information here in the show notes. But yeah, thanks again, guys.
Yeah, thank you so much.
Joe.
Yeah.
Awesome. Thank you, Joe.
Great. Well, yeah, thank you again for listening to the Fabrication Friday podcast, everyone, and happy printing. And that was an awesome podcast with the Victoria Hand Project people. Honestly, I can't say enough good things about them. They're a joy to work with, and it's going to be really cool to start working with them a little bit more here in the US. And with our first patient here up in Toronto that we're helping them out with. So if you are a patient that's in need of an upper extremity prosthesis and you've kind of exhausted all your other through insurance routes, or just otherwise are interested in the Victoria Hand Project, if you're a prosthetist seeing this as well, please do reach out and inquire about the Victoria Hand options. We do have a tech tip of the week this week. So our tech tip of the week this week is to prime your nozzle before printing. Why do we prime our nozzle before printing? Well, you want to make sure that that first layer is really adhered very well to the bed, but also that you just don't miss any corner or edge or part of your actual print before you actually start getting into the second and third layers. So what you can do to prime your nozzle is before the print, purge material through it. Make sure that you get out all of any old material that was inside the nozzle before that, and that you see a nice steady stream coming down throughout from the nozzle. If the stream is coming out to the side a little bit, then that might indicate a nozzle blockage partially. So just continue to do that until you get that blockage out. You could heat up the nozzle a little bit more to try to get any blockage out. But primarily you'll see it going straight down. In some cases, your nozzle might be worn out after thousands of hours of printing. Swap out a new nozzle and you'll get a nice steady stream going on. You could also use a skirt or a brim during your print. So with the skirt is going to be offset from the part. You could do an offset of say 3 to 5 millimeters if you have that enough build volume. And that just also is kind of a prime line going around your part so that the nozzle is ready to be spitting out material when you start that print. A brim could kind of do the same thing. You're starting to, spit out material before that print is actually being printed for your part, but the brim can also help with reducing some warpage. If you're seeing your corners lift up off of the bed, or otherwise you just are printing with a material that has a high amount of warpage, it'd be good to be using a brim in that case. So make sure you prime your nozzle, folks. Thanks for listening in to the Fabrication Friday podcast this week, and we'll see you in a couple weeks. Thanks.